Okay, good evening, everyone. It is 7 o'clock, so I'm going to get things started here. And first of all, I just want to thank everybody for joining us for what is our fifth and final webinar of our fall webinar series. So my name is Alex, and I am the climate change analyst here with the RDN. And tonight I'm joined with Jessica Bobier, who is our climate change and resilience coordinator and also the brains behind our webinar series and tonight's presentation. So Jessica will be our main presenter for tonight. But before I hand it off to her, I'm just going to take a minute to kind of outline tonight's schedule and also lay down a couple of instructions. So just off the bat, tonight's webinar will be recorded and uploaded to our website. So please feel free to keep your cameras off. There's really no need or requirement to have them on if you choose not to. And I'd also just like to ask everyone to ensure that their mics are set to mute. And you can do that just with the microphone icon at the bottom of your screen. You can just set it to mute or unmute. It is set to mute upon entry. I just ask that everyone just take a minute to double check that. I'm also going to be monitoring our presentation tonight. So if anybody does have any technical difficulties or if you get disconnected at any point, please feel free to email me or reach out to me. The Zoom room is open throughout the entirety of the webinar, so you can join back in at any time if you do experience a disconnection. And you can do that just through the link sent in the confirmation email from when you signed up. If you have any questions, we do have a lot of content tonight, so we'll be moving through at a pretty steady pace. And if any questions for you do come up, please feel free to type them down in the chat box. I'll be monitoring the chat box and I will reply to all of the questions that I am able to. Any ones that don't get answered throughout the presentation, we are having a question and answer period at the end of the presentation. So anything that gets missed during the presentation, we can bring back up again during the Q&A panel. And since we do have quite a bit of content, we are aiming to go a little bit past 8 o'clock tonight. So we are aiming for about 8:15. This just ensures that during the question and answering period, we do get a chance to answer all of those questions that might pop up and just really be able to dive into getting some of those questions sorted out, since they're oftentimes some of the most important parts. Finally, we are delivering this webinar on the traditional territories of the Coast Salish people. And I'd also love to invite everyone here tonight to also type in where you are tuning from just in our chat box below if you would like to do so. Again, thank you all for coming tonight, and I will now pass on the presentation over to you, Jessica. Thank you.
Thanks very much, Alex, and thanks everyone for joining us here this evening. This presentation is part of the RDN's Green Building Program. The program was established to help residents and the building community improve the sustainability of our built environment. It connects residents with useful resources, provides outreach and education to build awareness, and provides small stackable rebates for RDN electoral area residents. We've partnered with the Cowichan Valley Regional District for this webinar series, as our two areas share a lot of common goals in sustainability, and many of our residents also have similar interests and questions. So thanks very much for joining us today. If you're interested in checking out some of the recordings from our previous webinars on heat pumps, home energy efficiency renovations, or electric vehicle ownership that we did this fall, you can visit the RDN's Green Building Resources page. A link to this will also be included in a follow-up email. This is the last webinar of our fall series, so thanks to everyone who's joined us for the others. Today, we're specifically going to look at building new homes that are better able to manage some of the effects we anticipate from climate change. Now, this webinar is geared towards prospective homeowners, so we'll not be going into specific technical details, and it's more to build basic awareness and point towards available resources that can support along the way. We're going to start the presentation by reviewing some of the anticipated effects of climate change in our area and what this might mean for our homes, and then move into two main concept areas: sustainable site planning and home design for your changing climate. We'll then look at some of the incentives and finances available to help with the latter. There's a lot to go over tonight. I'm going to move through things fairly quickly, but we will be providing everyone with a link to the recording in a follow-up email, and also any links to references that are referred to throughout the presentation. So don't worry if you missed something. Let's get started. Okay, regional projections and the need for adaptation and emissions reductions. This past year has brought us some pretty wild weather extremes. Both the heat dome in June and the massive atmospheric river we had last week are really consistent with the type of weather projected to become more common in our area due to the effects of climate change. This creates a different level of risk from what we're used to and makes the need to adapt quite clear. And by adapt, I don't mean cope. I mean changing how we do things so that they fundamentally reduce the impact we experience from these climate events. This doesn't mean we're giving up on or forgetting about reducing emissions. It means we're preparing for some of the change that has already happened and likely to continue. We also need to think about reducing emissions. The built environment contributes about 25% to our local emissions profile in the RDN, and reducing emissions from this source is a key part of meeting climate change targets. This 25% does not include embodied emissions, which are all the emissions generated in producing and moving materials to the building site, and which can be very high depending on what building materials are selected. We also impact landscapes and their ability to sequester carbon by converting them from a natural state to a developed state when we build our homes. Fortunately, thoughtful development, design, material selection, all of that can reduce these impacts while also improving our capacity to adapt. So what does the future climate scenarios, what does it mean for our homes? Our homes face a higher likelihood of damage and safety risk. It means that we need to do a better job of maintaining the natural systems that buffer our homes from climate change, and we will need our homes to better protect us from more extreme weather events and their effects. Over 500 people died in the heat dome in the Lower Mainland area this summer. That's largely because their older homes were not capable of buffering them against extreme temperatures outside. Or it was, this has real impacts, and they were just homes designed for a different time. So we need to start thinking about things differently. And what is exciting is that we know how to site and build better, but this doesn't happen by default. You as the client, you have to make your priorities clear with your builder or your designer. Most homes are going to be built to the BC Building Code by default, which will give you a safe house that's moderately energy efficient, but fairly far away from what can be achieved in terms of energy efficiency and resilience. There are some fantastic builders and designers out there who are really engaging in these types of topics we'll discuss through this evening, and a lot of the building industry is really starting to pay attention to this and develop their practice to start looking at resilience and carbon reduction. Generally, we're seeing a policy shift towards emission and lower carbon that is also nudging the industry towards some of the methods we're talking about tonight. But the key takeaway is that you as a client need to bring your priorities for climate resilience as part of your requirements. They generally don't get integrated just by default. So if you don't ask, you will likely get a code-built house and miss out on some of the good opportunities for risk reduction. It will still be a very safe, well-built house. You just may miss out on some opportunities. So we'll start off with sustainable site planning. In the case of new homes, we have the luxury of deciding how to site and orient them within the bounds of regulations that are out there. Where we situate our homes has a big impact on how vulnerable they are to different risks and what impacts they have on the surrounding landscape. Because homes last for decades and it's very expensive to make major changes to buildings once they're constructed, these original decisions can lock in climate risk and the ability to make adaptive changes to the home for many years. And it can really influence what choices are available to you and to all subsequent homeowners. Sustainable site planning differs from traditional site planning in that it prioritizes how residential development coexists with the site's natural features and systems. It supports development that maintains natural processes on site and can also protect the character of the area, which is often what attracts us to an area in the first place. It considers the potential for intense weather and other natural hazards like fires and floods, and helps identify lower risk and lower impact site design options. The result is improved safety, reduced risk of costly damage and repairs, protected natural processes and natural character, and more resilient homes and landscapes. For example, this diagram here shows an approach where surface paving has been minimized and native vegetation has been retained, protecting groundwater recharge. This year, the RDN published a sustainable site planning guide specific to our climate and regional context. This guide provides background on key natural systems and processes and how they might interact with your home and the general area around your home. It also takes the reader through 3 key steps for sustainable siting and includes additional references to consult along the way. It also provides some examples of options to consider when working around specific types of natural features. And overall, it's a pretty great backgrounder for those looking to build in our area while also reducing their impact. A lot of the things in it lead directly into climate resilience. I'm not going to go too in depth into the guide because I think it's a great thing if you go and check it out yourself, but I'll touch on some of the core principles and how they influence climate adaptation for your home. A good time to use this guide is actually when you're purchasing, before you purchase a property, because what you look for might influence where you choose to buy. The core structure of the guide is a checklist approach that the user can follow, and it consists of 3 general steps. One is the local context evaluation, which is identifying features of the surrounding area that might influence risks or impacts your home will face. So this is area where you're actually building the home and own the land. It's in the broader landscape area. So it'd be things like major waterways, prevailing winds, those large forests that might pose a fire hazard, those types of things. Once you've sort of got a general lay of the land around your site, you move on to a specific site assessment, looking at natural features of the site itself and identifying what features you might want to protect or remove, what view locations might be there, what setbacks to consider, the path of the sun, shading options, et cetera. And all of these things use a checklist approach so that it really guides you through the different things to look at and consider. And then the last step is using all of that information you just gathered to create a sustainable site plan. And this helps identify those lower risk areas and beneficial building orientations that protect your home and the local area. I mentioned a lot of this ties into improving climate resilience. Throughout the rest of the presentation, I'm going to be using these icons to link specific measures back to the risks they address and the benefits they bring. As an example, a measure that has the thermometer beside it means it helps protect, just use my pointer. This one means it helps protect from extreme temperatures. One with the green leaf and plug-in means it reduces emissions and energy use. So they're all fairly intuitive, but just take a look for those icons as it connects back to risks and benefits. I'll briefly touch on some of the examples in the Sustainable Site Planning Guide and how they link to climate. It covers protecting and restoring native vegetation. So planning strategically to limit disturbance and replanting with native species where possible. Retaining this vegetation reduces erosion and landslide risk and improves water infiltration, which reduces need for irrigation and protects our native landscapes. This is all beneficial stuff when it comes to reducing our impact on the natural area and maintaining its ability to protect us from the effects of climate change. Protecting aquifer recharge is another topic. So limiting paved surface, using bioswales, rain gardens to manage surface flows, and clustering the development on the site. This presents some pretty good risk management for drought and also reducing the risk of overland flooding. The guide also gives some tips for working near specific types of features, sites near surface water, for example, avoiding floodplain areas, leaving more than the minimum required setbacks to protect riparian areas and rehabilitating some of those damaged areas while also minimizing paved surfaces. All of these help reduce flood risks and also maintain the natural processes that support the environment we rely on for well-being in our area. Working in coastal areas has tips for that, avoiding low bank areas and estuary, and then using green shores principles to protect your home from shoreline erosion instead of using hardscape materials. Green shores approaches maintain marine processes and do a better job of minimizing erosion from sea level rise or larger storms, while also maintaining better access, environmental processes and aesthetics. Again, there's a lot to, far too much to touch on in the guide within the context of this presentation. So I encourage you to go take a look when you have some time. It's available on our website, and we'll include a link to that. Just a note on additional resources that are very relevant here. The RDN publishes water smart resources and fire smart resources, including our Fire Smart and Water Smart Landscaping Guide, which has direct impact on how vulnerable your property is to wildfire risk and how much it contributes to drought. These cover topics like low irrigation and water smart landscaping and how to reduce fire risk around your home through vegetation management. Fire Smart also covers design choices for your home's exterior that can minimize fire risk, including different choices for siding, decking, and roof materials. So let's talk about climate adapted building design. Our existing BC building code has a lot of very good provisions in it. It has increased occupant safety and building durability over time. However, there's a lot of room for improvement when it comes to climate adaptation and mitigation. We commonly have in our current buildings quite complex building forms, and it doesn't always have a lot of attention to building orientation. And over time, these can make your home less resilient to external temperature swings, meaning that homes are less able to retain internal temperatures without using a lot of energy. And if storms take the power out, they can't maintain that comfortable internal temperature for as long. We also have a somewhat spotty quality of heating, ventilation, system design, and installation. This is a bit of a legacy of the industry where a lot of things were done by rule of thumb, which worked fine in our older home designs. It doesn't work as well with the new home designs. So that can be an issue at times. Those homes, the code-built homes are also in our area. They're frequently heated with either natural gas or maybe a baseboard heating system. These have some drawbacks. They also have some pluses, but their natural gas is a high carbon energy source, and baseboard heaters are not a very efficient form of electric heating compared to something like a heat pump, for example. We also commonly don't have cooling in our area, and that's nothing to do with the code. That's choice and what we've needed or not needed in the past, but it is something after the summer people are starting to think about more. And overall, there's across the industry fairly limited attention to the sustainability of the materials going into the buildings themselves. And that's all part of moving the industry along and people learning about stuff. So this is starting to change. And we are seeing some decent change happening. We will see significant changes to parts of the BC building code over the next 10 years or so, particularly around energy performance. But the takeaway is that if you as a client don't ask for more, you will get a code built home and maybe miss out on some opportunities. So how do we get to better than code? One common way is to use a building program standard, which can help ensure your home has the core features that help make it more resilient to anticipated effects of climate change. All of these programs include a focus on energy efficiency through good building design, with some more so than others. Some also include other elements for overall sustainability, like Built Green or the Living Building Challenge. Some consider embodied emissions, many do not. And overall, it can be useful to run through these programs to get ideas of what you may wish to include in your project. Just a note on the energy step code. It's currently a voluntary provincial energy performance standard. So local governments can opt in to whether or not they implement it. It is active in some areas. I know Nanaimo, I think municipality of North Cowichan, Lanceville have enacted parts of step code, but over time it is supposed to be brought into the BC building code, so it applies everywhere over the next 10 years or so, eventually requiring net zero ready homes by 2032. So we're looking for a scaling up over time. 2022, we're supposed to be at step 3, which is about 20% more efficient than a current code built home. 2027, we're supposed to be about 40% more efficient than a current code built home. And by 2032, they're aiming for step 5, which is about 80% more efficient than a current code built home. Whether or not this actually happens in the legislation remains to be seen, but that's the target they've let out so far. And again, just because your builder or designer has an accreditation in one of these programs, it doesn't mean they'll automatically apply things from those programs if you don't ask for them. So you need to be explicit about what you're interested in and be clear in your communication so that they can help you meet your expectations. And one of the key things, and some of these programs focus on this, is an integrated design process. This is a great way to get everyone at the table and have discussions that help identify issues with design or plans that could make your project more difficult, or if one part of the architect's design doesn't work with your mechanical installer's design or your mechanical system plan, that those conversations happen early when it's really easy to change things. It's just changing something on paper instead of ripping out a whole bunch of material. And you do pay a higher upfront cost for this process, but you avoid a lot of costly errors and end up with a better designed product. This is fairly common in the large building industry, but it is less common for houses. But if you want a high performance home, this is a great way to avoid costly errors down the line. So one thing that you might discuss in that integrated design process might be building orientation. As someone building a new home, you're in the fortunate position where you have control over the home's orientation at initial form. This is something you don't have if you're buying someone else's home. And these types of decisions both influence the initial cost of your home, but also have a fairly permanent influence on how prone your home is going to be to overheating and how much energy your home is going to demand, and consequently, what your energy bills are going to be. The Sustainable Site Planning Guide actually goes into some of this as well. Just when thinking about orientation, one of the key things to think about is minimizing the amount of west-facing window surface if there is no natural western shading, like a giant mountain or a big forest right next to your house. Western sides of your house, they can't be shaded with overhangs like the southern side of your house can be. The result is that the afternoon and evening sun comes blasting in to those western windows in what is already the hottest part of the day. So in summer, you can imagine how much that can overheat your home and lead to some pretty expensive heating bill or cooling bills. Orienting so the long side of your house faces south and using shading design to let winter sun in, but block out the higher summer sun, can allow your home to benefit from the rare winter sun events we get here, while also preventing overheating from all that sun we get in the summer. And just another tip, choosing a simple structure for your building is going to help reduce the costs of building a resilient, efficient home. It's a lot easier to add more insulation and manage the air barrier in a home that has a fairly simple structure. And just the thermodynamics of it all also make it sort of by design more energy efficient. Doesn't mean you can't do complex structures or take advantage of specific views. You just need to be conscious of these things and how they might affect things like the overheating potential of your home, and discuss potential solutions or alternatives with your builder. For example, using different windows on west-facing aspects that are more effective at blocking out solar radiation. So in addition to building orientation, when you're building a new home, you are in a great position to focus on an envelope first design. The envelope is the walls, roof, all the parts of your home that come into contact with the outside environment and protect you from the outside environment, includes windows and doors. It's much, much cheaper to do a good envelope from the start than it is to go back and make modifications later. This is envelope modifications when you're 10 or 20 years down the road, they're much more expensive to get to the same level of performance than if you do the building envelope right the first time. And if I were building a house, I would put my money into a good building envelope and not into the high-end shower fixtures, because those can be changed down the road. The building envelope changes are much more difficult and they give you much more back over the life of your home. So some of this is also about where you choose to spend. A good envelope protects against uncontrolled air and water infiltration and provides a good thermal buffer, so the internal temperature of the building is comfortable regardless of outside temperature. And in the past, we've compensated for a weak envelope design by cranking up the heat or cooling and just dealing with drafty, uncomfortable homes. This is not a good approach. It fails us in many, many ways. It's expensive, it shortens the building lifespan, compromises occupant comfort, and has a high environmental impact. We can do a lot better. So taking this envelope first approach really pays off throughout the lifetime of your home. Improved indoor air quality, better buffering against external temps and wildfire smoke, more resilience from stormy weather, and lower costs and lower energy and lower emissions. So how do we get a good building envelope? Air tightness is one of the best areas to focus on for this. Air tightness minimizes the uncontrolled movement of air through your house structure. Code-built homes frequently have air barriers that maybe aren't well protected from damage over the lifetime of the home, or have some gaps in them. There's currently no testing required for air barrier integrity in areas of the province where the step code isn't enforced. And this can result in your home being drafty, and it can make it difficult to protect against things like that wildfire smoke infiltration. When that's coming in through all of the gaps in your home, there's not much you can do about it. So a high level of air tightness also ensures ensuring long-term protection of the air barrier over time will protect you and your home. And just some general tips here. Discuss your objectives with your builder early on and ensure a specific level of air changes per hour, or ACH, as part of the design criteria for your home. This could be something like step code, which I think is 1 air change, or passive house, which is 0.6 air changes per hour. So having that goal to reach for is a great idea. And then asking for a design that protects that air barrier over the lifetime of your home is also a good option. One thing I'd recommend is really requiring a mid-construction blower door test. So before the drywall goes up, making sure that there is this air change per hour test that is done. So any issues that exist can be identified when it's really easy to fix them. It's very difficult to fix air barrier issues once all of the drywall goes up and the house is finished. And then doing a final blower door test. And then looking for builders who put extra effort into air tightness, either through training or through building of high performance homes in the past. So the last part of second to the last part of the envelope I'm going to talk about is insulation. We definitely have insulation in our homes now, but we still have relatively high heating and cooling bills and need a lot of energy to manage the internal thermal comfort of our homes. Insulation reduces the heat transfer through the walls, basement, and roof of your home, buffering the inside from outside temperature swings, which is going to become much more important as we move into a more volatile climate. Your home stays cooler in the summer and warmer in the winter using less energy. It'll also be better able to maintain its internal temperature if the power goes out, which, if we're going to have more intense storms, that's something I would see as an advantage. Does require additional costs up front as you're using more insulation, but this can be offset because you can buy a smaller heating system and pay less for its operation over your home's lifetime. Adding more insulation to your home can change how moisture and thermal dynamics work in your home. So working with a builder who's familiar with building science and the building as a system approach will help reduce the risk that problems develop in the future. Different approaches to adding insulation create different dynamics. So knowing what insulation products work together is very important, particularly for high performance building approaches. If you are concerned about climate change, be very careful about picking your insulation materials, because I mentioned embodied emissions earlier. Manufacturing processes for many insulation products create a lot of greenhouse gases. XPS foam board, for example, that classic pink board, spray foam insulation, insulated concrete forms, they can all have very significant impact on the emissions generated by your new home build. So it is something to think about, those embodied emissions, and I'll touch a bit on it later. Last part of the envelope I'm going to talk about is the windows and doors. These can let in a lot of heat if they're of poor quality or not installed properly. So invest in high quality, efficient windows and doors. Look for those Energy Star rated products. If you're really going into energy efficiency and the passive standard, look for passive products, and passive house rated products, and be conscious of placement. As I mentioned before, lots of windows on the western side can make your home very exposed to overheating, which is not compatible with comfort in the context of a high extreme heat event. Being careful to limit window to wall ratios can both reduce the cost to build your home and to heat it over time. It doesn't mean you have to live in a windowless box. It just means being aware of the trade-offs and having those discussions with your builder and designer. Remember, this has lasting effects on how your home handles overheating, the interior air quality of your home, wildfire smoke, resistance, and its ability to maintain its internal temperature when it loses power. And it will reduce costs and energy use over time. So now that we have an efficient envelope, we need to talk fresh air and indoor air quality. Our older homes defaulted to ventilation through uncontrolled air leakage through the building envelope, leading to homes that were too hot or too cold, mold buildup, moisture entering the building envelope, moisture damage to various building components. Uncontrolled ventilation through air leakage does not do us any favors. You may hear that a house needs to breathe. It does not need to breathe through the building envelope. This can all be handled through well-designed ventilation, and we want that ventilation by design, not by accident. Ventilation by design means your home receives the amount of ventilation it actually needs for good indoor air quality, moisture control, and comfort. Incoming air can be filtered to remove external contaminants so your home can be more resistant to things like wildfire smoke. A heat recovery ventilator added to that will also extract energy from stale air before it's expelled from your home, using it to heat the incoming air, saving energy. The result is that you get a much more comfortable home environment in a much more energy efficient way that is much more compatible with lower energy use. So for heating and cooling systems, which are often part of tied into ventilation systems as well, paying attention to building form and orientation and focusing on an airtight, well-insulated home, that envelope first approach, it means you can reduce the size of your home heating and cooling system because it's needing to meet a lower heating or cooling load because of these other steps you've taken. This reduces the initial cost of the system and the size of the ducting needed. It reduces the operating cost over the lifetime of that system, and it gives you more flexibility in what mechanical system you can use. Higher step code level homes or passive standard need only very small heating and cooling systems because they're already very resilient to those outside temperature swings because of all the attention to air barrier and insulation. Different heating systems have different impacts and efficiencies. You can see from the graph on the right that electric heat pumps in dark blue produce very few emissions. Emissions are on the y-axis here. And this is looking at emissions generated by different houses built, or the same house type built to different levels of the step code using different heating systems. So this bar here, the dark blue bar, is the electric heat pump. And you can see at step 5, it's quite low compared to natural gas in the bright green, where even at high levels of energy efficiency, step code 5 level, you're still having significantly more greenhouse gas emissions than if you're using electric sources. So this is something to think about as you're trying to figure out what heating system you want to use for your home. There are certainly trade-offs, there's cost trade-offs if you're going to move to something like a heat pump or look at different alternatives. And then there is the high-end option where if you're going for the passive house standard, you can often get away with just a heat recovery ventilator and maybe some small electric resistance heating or a coil in that ventilator. So there's what you do with the building envelope really has an impact on what you can use with a heating system. Just some tips around HVAC, so the heating, ventilation, air conditioning. I did mention that past practices in HVAC have been fairly loose, and there is some of that legacy remaining in the industry. Investing in good mechanical design and ensuring the mechanical designer and installer are both included in the integrated design process can really pay off, as does working with qualified HVAC providers like tech equality first contractors. It's a great idea to make sure you get all of the documentation of system balancing and verification. You don't necessarily have to understand it, but setting that expectation with your builder that you are expecting to see it, as well as get a thorough orientation to how the equipment works and needs to be maintained, can help go a long way to ensuring you get a good system that has been properly commissioned and tested to make sure that it's set to the character of your home. They may already be thinking about doing all of this stuff, but it's better to confirm expectations. So something to think about throughout the planning process for your building is the amount of embodied carbon in materials. This graph shows results from a study done in the Nelson and Castlegar areas. On the left, this big graph here, oops, my pointer's not working so well, this is the total embodied emissions of the homes in the study. And I believe this was modeled using assuming that all of the worst possible building materials from an embodied emissions perspective were selected, but these are still very common materials used every day in our homes. So concrete, XPS, foam board, those are used in building every single day. But what the point of this is that the emissions created by those materials, they really outweigh the emissions generated from the heating systems, the operational emissions of those homes. So you can see it takes almost 100 years for the operational emissions of the homes to match the embodied emissions created by building the homes in the first place. So it's something really to think about. It's been a bit missed in the industry and in policy up until now, but there is a huge shift towards thinking about this type of thing now. So I think there'll be a lot more discussion on this topic and policy developed in this area as we go. You as someone potentially building the home have the opportunity to use low emission products or even products that actively store carbon. So if you're interested in this study, the more information is available through a webinar that the City of Nelson put out on their YouTube channel, and the link is there. Again, it'll be included in the email. It's quite an interesting presentation. So tips for embodied carbon, let your builder know that you're concerned about embodied carbon. And as I mentioned, this is something that the industry is turning its attention to fairly recently. So you might have to lead the way on a lot of it. There are tools to help. There's the Builders for Climate Action and NRCan tools that are going to be coming out early next year, which might be of interest to your builder. They're compatible with a lot of the existing energy modeling, or the NRCan one. It's going to be compatible with a lot of the core energy modeling software that's already used. And there are already published environmental product disclosures for different materials that have been gathered into databases. I think Carbon Smart Materials palette is one of those. So you can look for materials that are lower carbon, and there's a lot more information coming out around both strategies for reducing carbon from things like cement and what alternative options exist for, say, carbon storing insulation products. So just a bit on costs. Upfront costs for building to a higher level of efficiency in those really high performance range can be higher. In our area, they can be about 2 to 20% higher. The cost is really influenced by many different factors. Risk of cost overruns will be reduced by using a simple building form. The more complex building you're trying to build, the more expensive it's going to be to build it to a high performance standard. Thoughtful design of orientation and placement of the windows, plus the ratio you're using for windows. Good design using integrated design processes. Are you working with a builder who's trained and has developed efficient processes for building these high performance homes? Are you doing that mid-construction blower door test so that you don't have to go back and fix mistakes after the drywall is up to get the air change target you're looking for? That one's a great cost saver. And then one way to think about this is really thinking about the total cost of ownership and the other values you're getting out of these upfront investments, like comfort, health, and resilience, as well as what can and can't easily be changed at a later date. So as I mentioned, I'd be more inclined to invest in my building envelope. Definitely not as interesting, but I would do that instead of spending extra money on expensive shower fixtures or a sink tap or something like that. So it's being careful about where you put your money. So what are the funding opportunities out there to help? There is unfortunately not a whole lot of funding out there for the sustainable site initiatives we talked about. Some of them are covered in our RDN sustainable development checklist, which gives points for putting in different types of positive environmental practices, including things like rainwater harvesting, xeriscaping, and those practices that can have a positive impact on the surrounding area and site. Most of the other programs are focused specifically on the home building elements, and they tend to be tied to either heat pumps or to different levels of performance in the STEP code system. So Clean BC Better Homes new construction, for example, that has it's unfortunately fully subscribed for 2021. We don't know if it's coming back for 2022 and beyond, but that had up to about $15,000 in rebates for meeting different levels of STEP code. And then the Fortis BC program is still accepting applications for this year, and it has up to $18,000 in rebates to assist with homes meeting a specific level of the energy STEP code. And the catch there is that it does need to be for Fortis customers. So you're either going to be, well, in our area, in the RDN and the Cowichan Valley Regional District, you would be connecting to natural gas to take advantage of that rebate, which you may or may not want to do depending on what your priorities are around carbon emissions from your heating system. So the RDN checklist is available to RDN electoral area residents only, and it can provide up to $1,000 in incentives for sustainably built homes. And just a tip, if you are an owner builder, if you're following that model, it's a great idea to invest in some training if you're not already familiar with these types of approaches. There are lots of options and resources available, and they can connect you with a community of people who are already interested in the same things. The BCIT High Performance Building Lab, they have Net Zero All-in-One course, which runs for about a semester and covers all elements of high performance building design with very good demonstrations of actual application techniques. So how do you apply multiple layers of external insulation, and how does it hold up to holding the cladding? All that stuff. So it gets very technical. It's a fantastic resource if you're interested in net zero building. They also have some hands-on lab. Canadian Passive House Institute has passive house design and construction courses. And then there's a lot of resources that are available to support via the BC Energy STEP code. So building design guides, that type of thing. So that wraps up my part of the presentation. Looks like we're actually on time instead of behind time like I thought we were going to be. So regardless of whether you're building yourself or having someone else build your home, there are a number of key takeaways from this. We do need to adapt how we site and build our homes. Following the sustainable site planning guide is a great start, even when you're looking for a potential piece of land to purchase. Referring to some of those other standards that are out there can also be very helpful. When you're actually building, going beyond the code and following the principles of high performance building, using that good orientation and starting with a good envelope first approach will have a direct application for the climate resilience of your home. Using that integrated design process and making those requests for things like the mid-construction blower door test and investing in good design for your heating, cooling, and ventilation will pay off over the long term. Then also keep tabs on what incentives are out there Do check in with the Clean BC program, because I am very hopeful that Clean BC funding for all electric builds will be coming back. If you are into natural gas, there is the Fortis program as well. And then considering the embodied emissions in your home, that is a big area of focus, and it's something we really need to start paying more attention to. So if you can be part of that change in building your new home, you'll be helping move the industry along in that area. And then most importantly, communicate these things to your building team and make sure they understand what you are aiming for in terms of sustainability in your home and climate resilience. And remember to focus on the overall benefits that come with building in this more sustainable way. So this is just a bit of contact information, Regional District of Nanaimo. If you have an interest in seeing those past presentations, there's a webinar series. You can get in touch with Alex if you have specific questions around the webinar, or to access the previous recordings here. There's also information on our rebate incentive programs from the RDN, and then also Clean BC Better Homes, and then contact information for Austin at the Cowichan Valley Regional District. So that's it for me. If you have any questions, I'll hand it back to Alex.
Okay, awesome. Jessica, thank you so much for that presentation. We do look like we still have about 15 minutes here, so we're going to enter our question and answering period. I'm just going to lay down a couple instructions for how we can go about this. So a few different ways for you guys to ask your questions. If you want, you can type them into the chat box and I can read them out loud for Jessica to answer. Or you can use the hand raise function, which is just down in the reactions. If you're on a screen, you have a reactions button. You can use your raise hand from there. Or you can just unmute your mic and go ahead and ask your question. And as long as there's not any overlapping, we can make sure those questions are all answered. So it looks like we have a question in the chat box. Jessica, I don't know if you had a chance to look at that one yet.
Yeah, I'm going to say that I don't know enough myself to answer that question definitively. I'm more familiar with seeing them in a conditioned airspace rather than an unconditioned space. I don't know, like to me, you'd put them in a place that's very accessible, one, so that you can maintain it more easily and that it isn't subject to the fluctuations of an unconditioned space. So my tendency would be to put them in a conditioned space, and that's certainly where I see them more commonly. But yes, I am not the expert in this area, so it's I would recommend finding a different definitive source on that.
This is Austin here from CVRD. I would say, first of all, it was an excellent presentation, Jessica. Thanks for inviting me along. I used to do the energy evaluations for new homes when I lived in Yellowknife for a while, and you definitely want to keep your duct work in the conditioned space as much as possible, and you'd want to definitely in a high performance.
Thank Austin. It looks like we lost you a little bit there.
Yeah, the gist I got from that was that yes, definitely have it in the conditioned space, which I agree with. I think it'd be odd to have it in the unconditioned space. So we might need to look at the graphics we've included here. So takeaway from that is put it in the conditioned space for sure. But even with that, like you want to be making sure that you are taking care of where you're running your ductwork and it doesn't go through those unconditioned spaces. I see Clayton's question. So Clayton's property doesn't allow for a south-facing home. Is it still worth investing in solar power? Trees around, concerned there won't be enough sunlight to offset the cost. So you can actually look up, pretty sure there's a resource out there that you can look up the solar potential of your property. I'm not sure if it covers our area. And it's always, I believe you can get someone to come out and assess the solar potential of your home without committing to the installation of solar panels later on. So sort of a feasibility assessment. If you do just have north facing, it's definitely going to be much more of a challenge to get the solar you need to offset the cost. But again, that's best assessed on a site-by-site basis. So have a professional come to your home and do an assessment of your property, and you'll be able to see from their projections. They'll give you a printout of the generation potential of the proposed setup, and you can get a sense of whether or not that's going to pay back the cost or how long that payback period will be, because they generally include that information in their assessment of your site. Oh, sorry, I didn't see this last bit. The roof faces east and west. Yeah, my recommendation still stands, definitely, especially with trees around, get that on-site assessment done.
Okay, and we'll just give a few more minutes here. I want to make sure everybody's questions get answered. So again, if you do have any questions that pop up, please feel free just to unmute your mic, and you can speak directly to Jessica or keep entering in the chat below. If not, we will have the follow-up resources that will provide all of the links and resources mentioned here in the webinar. So for you guys to be able to kind of go ahead and do a little bit of that self-research based on what we talked about. So hopefully those will also answer some questions that pop up later on down the road. And of course, you can also reach out to Jessica and myself. Our contact information will also be provided in that follow-up email as well.
I have a question for anyone who's willing to type their answer in the chat. I'm curious if you're considering building a home like the high performance home type with built-in, and if you are, what are the main barriers that you might think would prevent you from building a home like that? Yeah, cost. Cost is a common one. I've also heard from some residents that it can be hard to find a builder sometimes who is willing to build a high performance home, and especially these days when there's such a demand for building in our area. So there's certainly some challenges out there. Oh, if you're Clayton, if you're an owner builder, I really recommend the BCIT courses. They are online, so you don't need to go to BCIT for them. And they also have hands-on sessions in the high performance building lab where you can work with extremely experienced building professionals who have really got this down pat and share their knowledge with you in that lab environment. So, and it gives you a massive inventory of resources that they've put together that you have as a course participant. You have access to that for years after you do the course. So I really recommend that program if you're looking for more knowledge opportunities. Yeah, I think they're registering for the spring semester now. It's called the BCIT Net Zero Building All in One. So you register for that course, and then there's also separately, there are 2 hands-on courses in the lab. Austin's saying he's looking at the Sustainable Development Checklist online. We get some participation in the program. I think there's not as much awareness as there could be. So I think there are homes being built that would probably be eligible for those rebates that maybe don't know about it. So part of this is trying to promote a little more awareness of the checklist out there. I know of two homes at least this year have applied for it and received it. Great. Well, I don't see any more questions coming in. I need to up the incentives. Yes, that's. I'm actually doing a review of our rebate programs this year to look at different incentives that we might need to provide. Great. If there's no more questions, I think I'll hand it over to you, Alex, to wrap up our evening.
Perfect. Yeah, again, thank you for answering all of the questions that we had through there. And thank you to everyone tonight again for joining us on our final webinar tonight. I highly encourage, if you found some useful information here, again, please check out our previous recordings. They are all uploaded on our RDN webpage, which again, links will be provided in that follow-up email. And if you do have any questions regarding this webinar or anything that comes up in the other recordings that you guys watch, please don't hesitate to reach out. We have resources available, and if not, we can direct you into the right places. We're more than happy to do that. And again, keep an eye out on that follow-up email over the next couple of days here. Thank you again for everybody recording. Jessica, thank you for the presentations, especially for tonight. And Austin, thank you for joining us from the couch in Valley. Hopefully we'll see you guys all in the future and talk to you over the next couple of days as we answer your questions.
Thanks very much, everyone.
Okay. And awesome. I'm glad to hear about the learnings in the chat. So have a good night, everybody, and we will talk to you all soon.